Hello everyone, welcome to the webinar, Monetizing the Fourth Industrial Revolution Wave with 5G Private Networks, jointly presented by Comba and Intel. My name is Marima, General Manager of Comba Telecom Network Systems. I'm pleased to be the host for today's webinar and look forward to the insights brought to you by Comba and Intel solution experts, who will share viewpoints and approach to 5G private networks and how it can enable enterprises to embrace the Industry 4.0. Let us welcome our speakers from Comba Telecom, Mr. Kexing Moon, Solution Architect in Building Solutions and Open RAN. Kexing has extensive experience in building RF design and optimization and Open RAN technical marketing. We also feel proud to have our guest speaker from Intel to join us today. Let us welcome Mr. Dan Lynch, Intel FlexRAN Segment Marketing Director. We look forward to the insightful sharing from Dan on Intel's state-of-the-art FlexRAN software architecture and how it would benefit 5G vertical deployments. Today's sharing consists of 4 topics, which will be presented by Kexing and Dan jointly. Kexing will start from exploring the legacy, the challenges, and the enablers of 5G private network, and followed by sharing some reference cases from Comba. Dan will share updates on Intel FlexRAN architecture and follow with how Intel FlexRAN can bring value to 5G private network solutions. Without further ado, let me pass the floor to Kexing.
Thank you, Marie. Let's start from the background of Industrial Revolution. The first Industrial Revolution started in 18th century around 1780. They used water and steam power in production. Then, 100 years later, there comes second Industrial Revolution, where industry used electric energy to enhance mass production. The third revolution happens around 50 years ago. They used electronic and IT technology to automate production. And now we are moving to fourth industrial revolution, which is building on the third and extension of automations, adding characteristics of cyber-physical systems and connecting the physical to the digital world. The first 3 revolutions were mainly focused on production. Well, in Industry 4.0, they have extended the use cases to other sectors like logistics, transportation, healthcare, mining, and oil and gas. Industry 4.0 is not just a slogan. It is about leverage the AI and machine learning technology with industry applications, enhance automation and autonomous operation, enhance the data security as the data is the most important asset in any company, improve productivity. Enterprise also want to have a better control of the operational cost. This is definitely the key improvement that every company is looking at. And lastly, uphold workplace safety, such as in the mining, oil and gas sector, where people are working in the extreme environment. Anyway, the common goal is digital transformation. So what enterprise have today in their premises? Most of them are using either physical wired network or legacy wireless network like Wi-Fi to provide connectivity to the machines and sensors. The legacy wireless network are also deployed in an unlicensed spectrum. Usually, the existing systems are run in silo mode, where there are no data sharing between systems. All of them are operated individually. The pain point of these are poor mobility, require manual operations, low flexibility, difficult to do maintenance and troubleshooting, difficult to introduce new services and applications. And lastly, because of the no exclusivity when they're using unlicensed spectrum, it is exposed to interference. Industry use cases are segmented, each having its unique and dedicated requirement. Some of them even require a highly customizable network to support their daily operation. We can see here from the ABI research, the use cases in vertical industry are different. For instance, in manufacturing, process workflow automation and also collaborate robots and inventory management is important. This requires low latency network that can support as many machines, sensors, and IoT devices as possible. In mining, oil and gas, safety is the most important criteria. That's why we see video surveillance, real-time personnel location, and remote operations are in the priority list. There are also some specific requirements for the network equipment like explosion-proof, output power limitation that need to follow. On the other hand, in retail sector, in-store navigation, media and advertisement, customer behavior analysis are among the key areas of focus to improve shoppers' experience. Now, let us look at the network capability required to support these use cases. The chart here shows the bandwidth, throughput, and latency requirement of each application. The gray area highlights the services that could be enabled by 5G. From the chart, we can clearly see that 5G has advantage in low latency, less than 10 milliseconds, and also high throughput up to gigabit per second. With 5G, we can bring in applications like pre-programmable and autonomous driving like AGV, AMR, augmented reality, virtual reality, and tactile internet applications. Many more mission-critical communications use cases are also possible, such as remote surgery. After knowing the challenges and 5G benefit, we will now look at the key enabler of 5G private network and the current deployment and forecast from research paper. The first key enabler is the allocation of dedicated spectrum. Global telecommunication authority, such as the regulator, they have realized the importance of private network. So many of them have started reserve and allocate the dedicated frequency spectrum block for private network use. Here is the major market with private network deployed at the dedicated spectrum. They are in US, they use CBRS spectrum. In UK and Germany, they use N77 and N78. And in South Korea, they use N79. Many other regions are also following the trend and studying the possibility to plan and reserve the frequency block for private network use. The next is the key technology. The four key layers to form a private network are network itself, and then the platform, application, and the devices. In network layer, we have 5G new radio technology to provide high throughput, high capacity, low latency, and highly reliable network. In addition to that, NB-IoT, LTE-M, and ultra-wideband network will also provide a fit to various use cases. Second, virtualization and cloud technology can provide the platform to increase IT productivity, agility, and the efficiency to allow faster provisioning of new services. Open standards breaks the barrier between IT and operational technology system. This improves the interconnectivity between the various protocols. And here, edge will be the new frontier. For devices, the advancing technology in the semiconductors makes device integration easier and making sensors and IoT technology are accessible to the enterprise. Investing in a new technology is cost conscious. According to ABI research, they compare the profitability of status quo factory versus a cellular connected factory. The chart on the left showing the German automotive factory and the chart on the right showing a Japanese electronic factory. The analysis shows that in over 5 years, cellular connected factory will generate 4.9% increase in the gross profit in a tier 1 Germany automotive factory. And In 5 years, it will be generate 7.1% increase in gross profit in a tier 1 electronic factory in Japan. In other words, remaining status quo may pose opportunity cost risk in long term. Now, let's look at the current deployment trend. According to a report by Analysis Mason, private network deployments, most number of private network deployments are in the manufacturing sector. The trend is followed by transport, mining, and oil and gas. It is clearly shows that 5G cellular network is adopted more in manufacturing sector. This also shows that 5G plays an important role in Industry 4.0. And then the statistic on the right, showing the number of network deployed according to region. The top regions deploy private network are Western Europe, North America, and China. From the chart, we can say that with government or authority support in terms of incentive and localized spectrum, it definitely is a catalyst for the development of private network. Then from another report, also from Analysis Mason, they forecast that the number of private network will grow quickly from less than 800 in 2020 to more than 20,000 sites by the end of 2026. Now, I would like to share our experience in building 5G private network and some of our reference case. This is the network architecture of Comba 5G small cell for private network, which is based on Intel FlexRAN software. The RAN part consists of 3 elements: 5G AU, which is the baseband unit, 5G SW is the switching unit, and the DP is the access point. We also have high power RRU for outdoor deployment. This system supports 2 types of MEC integration. We can either integrate it together with the AU, or we can integrate it in a standalone MEC server, where the vertical applications are deployed and processed. This system also supports local breakout to ensure the data security, because the data will remain on-premise. The system also supports local UPF to process low latency data. It also can connect to CPE, LoRa, ultra-wideband, and Bluetooth beacons to support use cases, enabling vertical industries such as factory, mining, and even further extend to construction and hospital. We have demonstrated 5G manufacturing use cases, and here are some of the examples of how 5G private network helps in factory operations. The 5G private network enable many useful use cases such as cloud-based AGV, AR remote training, face recognition access control system, 5G AI testing, and cloud-based computer vision for AOI. With 5G technology, we have enhanced productivity by 30%, enhanced inspection accuracy rate by 20%, and reduced manpower by 60%. Here is another reference from mining case. The solution support use cases such as automated coal extraction, underground staff positioning in real time, AR remote training to assist underground staff to do maintenance and troubleshooting, AI-assisted camera to detect poisonous gas or collapse in the underground environment and trigger alarm in advance in the event of emergency. This system also supports redundancy, where it has 2 core networks deployed, one above the ground and another one in the underground. So in case if either one of them goes down, the another one will operate and maintain the communication services. This solution has helped our customer to enhance data security with fully on-premise deployment, enhance productivity by autonomous operations, and reduce underground manpower by 75%. To summarize what I have shared, industrial enterprise has a strong demand in 5G connectivity, but these solutions must be closely tied up to industry application to make sure seamless communication between people and machine. To maintain competitiveness in the market, enterprise is strongly recommended and encouraged to embrace 5G private network technology. This is my last slide. I will now pass the floor to Dan. Hello, Dan. The stage is yours.
The RAN really has been one of the most difficult network elements to convert over to a cloud-ready platform since that whole NFV journey started many years ago. Some of the big challenges for this cloud conversion have been, and have past tense, real-time latencies, the interoperability between the radio unit, the RU, and the digital unit, the DU, and the DU implements the baseband of packet processing. And that connection has been a vertical solution with very complex interfaces. And the availability of a performant software stack has been a stumbling block in the past, and also the availability of cloud hardware products to fit into the more challenging existing RAN real estate. So we've worked hard to enable the ecosystem with a performance software platform. We've addressed the real-time technical challenges. Definitely seeing a momentum change here in the industry. FlexRAN and now O-RAN is clearly having a positive impact on the interfaces, and that's really enabling a standard which is not just standardized, but is actually openly adopted and encourages interoperability among all the supply chain into the operators. It's not a light switch. You know, it's not suddenly cloud everywhere. It's an evolution which will take time. Notice we actually as well, we are seeing an increase in the type of deployment models here. You know, Cloud RAN, FlexRAN really was explicitly linked to central RAN, but that's no longer the case with private enterprise, stadiums, rural use cases really come to the fore for commercial deployment next year. So what we've done, more details on the FlexRAN architecture, we've built a reference platform to enable early adopters build product. The architecture itself is a combination of hardware and software components. You can see at the top, we've done a lot of work with ONAP to really demonstrate an end-to-end network. And the major, in the next row down, you see the major components in FlexRAN are that the 4G, millimeter wave, and sub-6 gigahertz 5G pipelines, as well as layer 2, layer 3 enabling libraries. Intel's major R&D is on the layer 1 side of these pipelines, and hardened versions of layer 2, layer 3 will come from the ecosystem. Radius, for example, they've done a lot of excellent work here, and we provide a binary Radius stack as part of our enabling kit to our customers. These pipelines sit on top of the FlexRAN SDK, which is really at the heart of FlexRAN. These are smaller, finer modules. This is where we see a lot of the heavy software optimization and reuse of our software from all our customers. To the right of that, you see the task controller, and that's the framework which knits it all together, ties it all together, and meets the real-time requirements for 4G and 5G. 5G is certainly making it much tighter. We recognize there's a lot of different frameworks out there, so we've designed it in a fashion that it's easy to swap in and out. The front-end gateway, enables that digital unit or DU RU communication, and network slicing. We're actually going to get into that in a bit. So we validate our software packages on Windows, CentOS, and it's great to see commercial real-time product offering from the likes of Red Hat as well to enable our FlexRAN ecosystem. And then at the bottom, that's what we said, right? The Intel, we're the silicon manufacturing company. We sell the CPUs, the network cards, the acceleration options, the FPGAs. Very, very important to enable the glue here.
Thank you, Kexing and Dan, for sharing your insights today. We've learned the importance of 5G private network to industry and how Comba's solution leverage Intel technologies to help enterprises achieve digital transformation. Comba will work closely with Intel to enable the benefits of 5G private network and bring value to our customers. If you have any questions regarding 5G private networks, feel free to contact us. Have a nice day. Goodbye.